For this problem, our directions tell us to model with a linear equation. So we've talked about a linear equation before, and we know that that would have the formula y equals mx plus b. And it says then, solve the question. So let me read. We have a picture, and it says a cathedral ceiling is shown in the figure. How high is the ceiling at the east wall? Well, not really knowing which is east and west and by how it's located, the only height that I actually don't know is the one to my far right. So I'm going to assume that this is the east wall. Now, I don't have any words. I'm used to, with a question like create a linear model or a linear equation, having ordered pairs. So what I want to think about doing, and this is very difficult for me to draw with my stylus, but I want to think about superimposing a coordinate plane. So this first part of my coordinate plane, the y-axis, I'm going to put right on top of this western wall. And the x-axis, I'm going to put right along the floor of the building. So this roof, which it referred to as a cathedral ceiling, this is my line. So my line is this diagonal line that follows the roof line. And so I have an ordered pair right here for this first wall, an ordered pair right here for the second wall, and then the ordered pair up here that I'm trying to figure out. So because of how I drew my y-axis to be right on top of this wall, the ordered pair here is known to me. And that is that I go over 0 in the x direction and I go up 8 feet. Because it told me it was 8 feet, and I drew my axis such that the origin is right here. So this point down here, we don't need it, but it's 0, 0. It's right at this corner of the building. And so that makes this my x-axis. Then my second ordered pair. Well, along the x-axis, I see that this little hallway between the left side and the next wall is 3 feet wide. And so that means that in the x direction, I have moved over 3 feet. And I see that the height of the ceiling there is 10.5 feet. So I have that second ordered pair that I've gotten off the diagram. And now I'm going to use these ordered pairs to create that linear model. So in that linear model, the first thing I need is slope. And I know that it's y2 minus y1 over x2 minus x1. And so the slope in this situation, my y2 is 10.5, my y1 is 8, and my xy is a 3 minus 0. So that gives me 2.5 over 3. And I definitely prefer decimal, and so I divide that out, and I have 0.83 repeating, and WebAssign often asks us to use 4 decimals, so I'll go with 4 decimals for my slope. Now, we know that B is the start for the y-intercept. And we are able to find B by plugging in the slope and plugging in an xy ordered pair. But in this case, because I located the building directly on top of the y-axis, I actually know the y-intercept. So this 8, this starting point, is the y-intercept. And so without doing any additional algebra or math, I can write my formula. So my formula y is equal to 0.8333 x plus 8, because that was my starting point on my y-intercept. So the first thing it had told me to do was model with a linear equation. So check, I've done that. And so then solve the question. So now I have to figure out how high is the east wall. Well, I'm looking at the east wall, and the one thing I notice about it is this number down here, that it is 17 feet removed from the west wall. So that east wall is 17 feet away. Well, that 17 feet is clearly a horizontal direction. And so since it is horizontal, it is an x value. And so in my formula, I'm going to plug in y equals 0.8333 times 17, putting that in for the x, plus 8. And then I literally am going to go to a calculator and do that math. And I came up with 22.16, and the 6 repeated. So y equals 22.17 if we round off feet. And so there you have how an answer to that question, based on the really key is that we got this formula and then we just plugged in that x value. So the next one, you want to install a light in the ceiling as close to the east wall as possible, but not higher than you can reach. You can reach 16 feet. So we just found that this east wall is 22 and a little bit feet high. We can only reach 16 feet. So I'm going to say right here is my approximation. There's my light bulb, light coming out of my light bulb. And what I'm supposed to figure out is how far from the west wall. So if I draw a dashed line down here, hypothetically this is straight, and I want to know how far. So how far from the west wall? So how far is this? Well, so we said our light bulb has height here of 16 feet. Well, height is always a y value because it's vertical. So if I take my formula and I know that the y value is 16, I can put that in for the y. And then I put the rest of my formula. And then I just have a couple steps of algebra, and I can figure this out. So I'll subtract 8 on both sides. And so that gives me 8 equals 0.8333 x, and I divide by 0.8333 on both sides. And that will give me x is equal to 9.6 feet. So this question mark, I would need to be 9.6, almost 10 feet away from that western wall. So to go back and summarize, what are the key things? So the first thing I did is I wrote down what my linear equation is going to be, and then I drew a coordinate plane on top of the picture. So one of the key things was to add the coordinate plane. And adding the coordinate plane is what allowed me to see the different points and distances as ordered pairs, which allowed me to then create a linear model. So I added the coordinate plane, and then I was able to use ordered pairs to find slope. Once I had slope, I could figure out a linear equation. And then when it comes to solving the questions, here the 17 was x because it was horizontal. And here the 16 was y because they were talking about a vertical distance.